Hey guys, this is Ms. Brizenda, and we're looking today at lesson 5.4, scale drawings. So I apologize for my voice. It's a little rough. I seem to be losing my voice a little bit. And I'm also going to apologize in advance for my handwriting. I'm trying out the Mobi board today instead of using the Smart board, so I'm not as skilled at it yet, so hopefully I'll get better quickly. Okay, let's start by writing down the vocabulary words: scale drawing, scale model, and scale. And don't forget to highlight those in your glossary as well. So the first term that we have, scale drawing. A scale drawing is a proportional, two-dimensional drawing of an object. So for example, blueprints to a house. That would be a two-dimensional drawing on paper. A map is also a scale drawing. The second term is a scale model. A scale model is a proportional, three-dimensional model of an object. So you could take that two-dimensional blueprint of a house and create a three-dimensional model that actually shows all the walls and all the parts of the house, not just flat, but in three dimensions. The last term that we have is scale. A scale is a ratio, which also means fraction, that compares the measurements of a drawing or a model to the actual measurements of the object. So make sure you have all of those terms written down, and then we'll move on. Okay, it's important to notice that the definition of scale says that it compares the measurements of the drawing or model to the actual measurements. And that's important, that you make sure that the drawing or model distance comes first in the ratio. And then you'll put the actual measurement in the second half of the ratio. So I'd like you to draw this diagram in your notes. You can see that they have the drawing distance first and then the actual distance. Whether you write your ratio in this form with a colon, or if you write your ratio in this form with a fraction bar, we would do the drawing distance on the top and the actual distance on the bottom. Remember that we read fractions from the top to the bottom. So the drawing distance comes first and the actual distance comes second. We have one more definition before we do an example, and that is scale factor. Scale factor is a scale written without the units. In order to do this, you have to make the units the same first. So when we look at this diagram that you put here, 1 inch to 10 miles, that's a scale, but it's not a scale factor because they have two different units. This one has inches and this one has miles. If we wanted to find the scale factor of that scale, we'd have to convert those miles into inches. Once we have both units as inches, then we can just compare the two numbers without the units. So let's go ahead and do the first example. Actually, the only example we're going to do today. There are two other examples in your textbook. They deal with using a map and a ruler to find the actual distance. So if you want to check those out, you certainly can. So here we go with the Mobi. Let's see how messy my handwriting is. Okay, so we're going to do example 3. And yeah, that was a great start, wasn't it? Let's see, try that again. All right, well, it's a little better. Okay, so this is a scale drawing of a spider. And in the drawing, this is amusing, isn't it? Okay. In the drawing, the spider is 5 centimeters. Okay. So if they tell us that the actual spider and that's not terrible, is 10 millimeters. Well, that's good because millimeters are smaller than centimeters, so that means the spider is smaller than this which is good. I like small spiders much better than I like big spiders. So they want us to do two things. They'd like us to first find the scale. And then second, they'd like us to find the scale factor. All right, well, that wasn't horrible handwriting. I think you can almost read it. Okay, so let's start with part A. Oh, that was terrible. Maybe I should stop doing circles. Or we could call them ovals. That would be great. Okay, so remember to write the scale. We have to do the drawing distance. So the drawing length divided by or over the actual length. Okay, so in the drawing we can see that the spider is 5 centimeters. And the question told us that the actual length of the spider is 10 millimeters. So we know that we never give a fractional answer without simplifying. So we have to look at that. And 5 and 10 are both divisible by 5. So 5 divided by 5 is 1 centimeter. And 10 divided by 5 is 2 millimeters. So 1 over 2 is simplified. That means that that's a terrible T. That's a little better. Scale is 1 centimeter to 2 millimeters. And I'm going to just highlight that answer. Okay. So now we'll look at part B. All right, that wasn't horrible. All right, part B, we need to find the scale factor. And remember up here we looked at the definition of scale factor. It's a scale written without the units, but we have to make the units the same first. So we're going to write the scale. You're probably having no trouble keeping up with me today. I'm writing so slow. With the same units. Okay, so looking at that scale, we have 1 centimeter and 2 millimeters. Well, I know that 1 centimeter equals 10 millimeters. Remember, if that's not something you have committed to memory, you could look on your reference sheet. You should have one in your binder. You have one in the back inside of your textbook. There's one on the Big Ideas Math website. You could probably just Google it. How many millimeters are in a centimeter? Okay, so 1 centimeter equals 10 millimeters. Well, that makes the scale factor really easy to find because let's write down the scale first. We have 1 centimeter to 2 millimeters. Let me move this up just a little bit. And I know that 1 centimeter equals 10 millimeters. So 1 centimeter equals 10 millimeters. That was very easy to convert. And I'm not going to change the 2 millimeters on the bottom. The whole point here was to make the units to be the same. Whoops. Okay. So now that the units are the same, I can get rid of them. And now I don't just have the scale, I have the scale factor. The scale factor is 10 to 2. But, whoops, I said 10 to 2, and then I started to write something else. 10 to 2. But remember that we are not allowed to have any fraction answers that are not simplified. So I can divide both of those by 2. 10 divided by 2 is 5, and 2 divided by 2 is 1. So that means that the scale factor is actually 2 to 1. I'm sorry, 5 to 1. And I'm going to highlight that. Okay, so to summarize the lesson, we learned that measurements in scale drawings and models are proportional to the measurements of the actual object. Don't forget that there are lesson tutorial videos on the Big Ideas Math website if you want to see some more examples of this kind of thing. You can try the odd problems in the textbook and check the answers in the back of the book. And I will see you in class.